Good morning, everyone. Welcome to day 3 of the Global Navigation Satellite System specializing in reflectometry capacity building workshop jointly organized by IEEE GRSS and IEEE Student Branch of KEL University, Hyderabad. Over the past 2 days, we have dwelled into various aspects of GNSS-R from fundamental concepts to specific applications. Today, we will continue the journey by examining real-world case studies and applications, followed by discussions on research opportunities and funding support. So today we have Dr. Rajat Bindlish with us. Welcome, sir. Now, I would like to invite Ashit to introduce sir.
Dr. Bindlish is a research astrophysicist at NASA Goddard Space Flight Center focusing on microwave remote sensing application in hydrology. His contributions include developing soil moisture algorithms for missions like EMSRE, SMOS, AMSR2, Aquarius, and SMAP. He currently serves as the Deputy Project Scientist for SMAP mission, and he is a science team member for the NISAR, Aquarius, and GMCOM-W missions. Dr. Bindlish earned his PhD in civil and environmental engineering from Pennsylvania State University and received the IEEE GRSS Highest Impact Paper Award in 2015. His expertise in soil moisture algorithms and satellite missions makes him uniquely qualified to speak about GNSS-R applications in Earth observation. I would now like to invite Dr. Rajat Bindlish to present on GNSS-R applications and case studies. Please join me in the welcoming Dr. Bindlish. Dr. Bindlish, now you can take over the session.
Yeah, we can hear you and see your screen. Please go ahead.
We will go over a bunch of slides that I just put together. NISA, since NISA is slated to be launched very, very soon in the next couple of months. And I'm sure everybody in India is very, very eager to see NISA data and would be likely will be working with NISA. So I'll try to go over some of that material on NISA also. So to begin with, microwave remote sensing can be done in a number of different, using number of different technologies, and the three technologies which have been widely used have been passive microwave remote sensing. This technology is probably the oldest, along with active microwave, which is radars. Uh, in case of passive microwave, you only have a receiver, you have no transmitter, essentially you have only a single satellite, and then it just observes the natural emissions coming from the land surface. Whereas in case of active remote sensing, you have a transmitter as well as a receiver on the same platform, and then you observe the reflected signals. So it sends a signal and then receives a pulse back, and that's what you observe using active microwave radar. In case of reflectometry, you only have a receiver and the transmitter is somewhere else, or somebody else is paying for the transmitter, and you're only observing the reflected signal. I'm sure this was covered by multiple people. So this is somebody else's satellite sending a signal, like for example GPS, and this is your satellite, which has only a receiver, and you're just receiving this signal reflected off the land surface. So essentially, there are three different technologies that can be used for getting similar type of observations, and they can be in different parts of spectrum. In this case, we're talking about mostly observations which are made at very low frequencies using either one of the three technologies, and each one of them has their own advantages and disadvantages. And I'm not going to get into that, but I'm happy to answer any questions if you have any future. Reflectometry is definitely the youngest of the three technologies as compared to passive microwave and active microwave. It started only about 2 decades back, and these are the list of GNSS-R satellites. There are 2 slides, I could not fit on one slide. It started with a DMC and Tech Demo Sat, and then later on that led to the Cygnus mission, which was launched in 2016. And after the SMAP radar failure, we turned around and decided to use the radar and a receive-only mode, and it has been collecting GNSS-R observations using the SMAP radar. So that's also a GNSS-R receiver. And then you also have Spire satellites, which have been launched. They've launched a number of Spire satellites over the years, and they have global coverage. So some of them have limited coverage. DMC and TechDemoSat was basically technology missions, which had very limited coverage. And these are some of the publications that talk about these satellites. Whereas Cygnus has been wall-to-wall coverage, but it only covers the mid-latitudes plus minus 37 because it's in I lost up it space station, so it only covers the mid-latitudes. SMAP, as you probably know, is polar orbiting, so it has global coverage, and Spire has global coverage satellites too. Besides this, there are other satellites which I'm less familiar with. Some of them, for example, Bifeng and others, I only was able to gather information of publications, but I have no knowledge about some of these Chinese satellites. The other one which is of interest is the hydro GNSS. I'm sure this was touched upon by others in the earlier during the week. And it's an ESA mission which is slated for launch sometime this year or next year's timeframe. So besides the first two, the rest of them have been science-driven satellites for commercial satellites. So, not sure how many of you have, you probably have used a lot of Cygnus data, but maybe not some of the other satellites, and you're probably planning to use hydro GNSS in future. That will be available from ESA. So these satellites, as you saw in the applications, they cover a number of different fields from wind speed, which was the main motivation behind Cygnus when it was launched, and then other application that has been widely used has been soil moisture and SWE or snow. Besides that, they have also used GNSS-R observations for doing inundation mapping, freeze-thaw state, sea ice. Those are some of the other applications which have been for which it has been used. So each one of these technologies, as I mentioned earlier, when you're looking at a particular application or a science, it has its own strengths and weaknesses in terms of resolution, accuracy, revisit, and those type of questions are different for each one of those applications. Some of the applications which I'll touch upon during this presentation are related to vegetation or vegetation transmissivity, and then freeze thaw, and then briefly touch upon snow. I believe Rashmi covered a lot of the snow stuff, and devote most of my time on soil moisture and agriculture, and then quite a bit of time on NISA. So this is more of a general chart. There are a number of different components of Earth's water cycle. Some of them are on the atmosphere side, some of them are on the land surface side, and we will be looking at some of these application water cycle components, namely soil moisture, permafrost, and snow, using these observations. I don't have any slides on inundation or reservoir mapping or those type of things, but that's another application you can do using GNSS-R observations. So one of the questions that generally comes is, where is Earth's water? If you just look at the total amount of water that's there, most of the water, 97% of the water roughly, is in the ocean. A very small portion, which is just 2.5%, is actually fresh water. Rest all of it is saline, which is the only water that humans can drink, essentially, unless you have to do desalination and all that stuff. You're not going to get into that. Within the 2.5%, which is the fresh water, it is broken down into glaciers and groundwater, which is the main component, fresh water. And glaciers, which is and ice caps, for example, Antarctica and Greenland, they constitute about 69% of the fresh water. 30% of the fresh water is in groundwater, which leaves only 1.2% of the fresh water. First of all, fresh water is only 2.5%, and then out of which only 1.2%. After that, it is 0.1% of the total water is the fresh water that you have in reservoirs or soil moisture or lakes or rivers. And out of that, when you look at this 1.2 and break it down even further, a lot of it is in ice and permafrost, and then lakes are a big component. Rivers and soil moisture and other parts and atmosphere is less than 10% of the fresh water that's there on the surface. So it is this very small component of the water that we are after, because that's what we humans live on, and which is the one that actually is the water that gets recycled all the time. It drives the water cycle of the earth. So what GNSS does is, you probably have seen this site before, and I will go through some of these applications during the presentation. You have a transmitter, and then you have a receiver over here. You have a direct signal and you have a reflected signal, and you can do a number of these applications. For example, permafrost or freeze thaw, biomass or vegetation transmissivity, and soil moisture and surface water are some of the applications that you can do using these observations. So one thing I wanted to say, please stop me at any point. If there's any question, just raise your hand, and Rashmi, just let me know if there's a question so I can address the question right away. I'll try to use a single charts to give an overview of the study, and a lot of these charts are actual papers. There's a citation at the bottom. The intent is to give you a very brief overview, and if you're interested in a particular science or application study, then you can certainly look at the journal paper and then read through it and look at all the clothing details of the work that they have done. So the objective is not to provide you with a very detailed application on a particular thing, but give you an ensemble examples of the different studies and how they've used the data from various satellites to do science studies. So the first one is some of the work that Liang Sang and others have did, where they basically developed Maxwell's equations to try to do soil moisture as well as vegetation. They're using very detailed physical modeling and come up with estimates of both soil moisture as well as transmissivity. And this is a very recent publication that was published this year. This they did using the data that was collected in 2022 over a field experiment that we did in Massachusetts, USA, where they collected the GNSS signals, and I will show you some other future examples on the following slide. All the data was collected and how some of the work was done. And they also used LiDAR data along with GNSS data to come up with these estimates, because as you can imagine, running full 3D Maxwell's equation requires you detailed geometry of the plant and other things which were obtained using LiDAR data. So next, I'll talk about how the GNSS data was collected, as well as the ground observations that were collected as part of the study. So this was done using destructive sampling. They cut the leaves and branches for doing ground truth, and then use cameras and other things for doing tracking and phenology mapping uh, over the growing seasons. And also they had tree dielectric permeability sensors deployed in the bark of the tree to monitor the sap flow. We also did LiDAR uh, observations during the experiment, and also they also had GNSS-T measurement. The reason we had T is because that's a transmissivity. So instead of having a satellite, you can have a GNSS receiver, which is using just a cell phone. So what my method is group did, they used a dog with a GNSS receiver, and they had somebody either walk through the forest or the dog robot go through the determined track in the forest and then try to map that and then also observe the relate the observed signal with the LiDAR observations and other observations which are made over the transect. So they were able to get a very good comparison between the transmissivity that the robot observed with the data that was collected from other sources. And this is basically was done over both two sites, one in Massachusetts as well as the other site in New York State, upstate New York. And they did it for Massachusetts is more mature, dense forest. New York is sparse forest, but they're both forest locations. Next study is about using GNSS-R for doing freeze thaw, especially for the northern latitudes. It's a study that was done using SMAP GNSS observations. They used SMAP data along with the machine learning algorithms to do star mapping, and they also provided the validation statistics, and then were able to have an accuracy about 95 to 99% depending on the season, locations. So obviously, as you can imagine, freeze thaw has a number of different applications because freeze thaw is the one that determines the GPP or greenness or carbon cycle triggering, because when the vegetation is in frozen state, the carbon cycle is essentially turned off because the vegetation is transpiring, it's in a dormant state. Once the vegetation is no longer frozen, then the carbon cycle starts off, and then trees or vegetation grow. And they, Chris Durkison and his group, they related the growth length of the thaw period with the GPP for different land cover types or different forest types in Canada, and they've had a relationship for each forest type or different forests and boreal forests and all. They have different relationships, as you can imagine. So that's a nice study that they did with related the freeze thaw with GPP. Next, there was a study that looked at the northern latitudes again using a different satellites for doing freeze thaw, and then these people looked at the onset of the spring and the duration of the thaw state related to uh, GPCP and SIF from modus, and they show that the transition period and the duration has a big effect on GPP. This is another study where they use the GNSS-R data and for a different science topic, which is try to do sea ice and density and thickness. As you probably know, uh, altimeters or ISAT2, for example, can do a pretty good estimate of sea ice thickness for deep sea ice or thick sea ice. But they have a problem with thin sea ice because the way they do the sea ice thickness is using a freeboard technique where everybody knows that 90% of the ice is actually under the water, only 10% of the ice is above the water. So if you know the mean sea level and then you know what the elevation is above the mean sea level, then you should multiply by 10 and you know this is the thickness of the sea ice. But as you can imagine, when the sea ice, the deviation from the mean sea level to the top of the sea ice is very small, the error becomes big. So it's challenging to do thin sea ice using LiDAR observations. It has been shown that radiometers or reflectometry can do a better job when they're looking at thin sea ice, which is also very important for navigation, as you can imagine, for example, and also doing climate change studies. Next, I will touch on snow. So those are some of the slides that talked about vegetation transmissivity of freeze thaw or sea ice. In case of snow, I'll probably give a very brief overview. And I heard Rashmi touched a lot on the snow work that she has done. Snow is a very important source of water for millions of people. It's the one that controls or stores the water during the winter season, and that becomes available during the summer. As you know, in India, the northern rivers, Ganges, Yamuna, Indus, and Indus and Panchas and Brahmaputra, all those catchments are in the Himalayas. And during the summer, the water you get before the monsoon hits, the water actually snow melt of the Himalayas. So that's what provides you the water resources. That's the reason snow becomes very important. And then, as you can imagine, snow melt is very important for doing flood mapping and disasters. I think. And obviously, we already talked about water availability, which is very important for irrigation and agriculture, as well as it's very important for generating hydropower and for industrial use. So it's a very important variable for just as a natural resource as well as for economy. Not only is it a water resource, but it's also important for energy balance. Snow, the albedo, uh, the snow determines the albedo of the land surface with snow and without snow is very, very different. Snow is very, very reflective as compared to thawed or non-snow surface is a lot more absorbing as compared to the snow surface. So it reflects 85% of the solar energy, so it's a big source of energy balance equations. It's also very important for wildfires and in case of droughts. Snow is what determines the water reservoir, especially the northern latitudes. And if you don't have a big snowpack or it is very dry, which will probably lead to very dry conditions, and that increases the probability of wildfires in the northern latitudes. Last, but not the least, snow melt, especially rain on snow, can lead to very large scale flooding. Uh, and I will go a little bit of detail in a later section where we'll be talking about agriculture, where we will see some of the implications of 2019 floods in the US, which were a result of rain on snow melt, rain on snow resulting in rapid melting, and that resulted in large-scale flooding. These large-scale, this large-scale flooding led to very, very wet conditions. If it is very, very wet, that resulted in uh, delayed planting, and that had implications in terms of agriculture and crop yield. And there were agriculture losses total 33 billion dollars in 2019 just because of this flooding. And partly the flooding was because of the snow melt, and then partly the flooding was because the rain that happened in the spring and summer that year. Uh, Next, we'll go on in depth on the soil moisture side, and I'll be using a number of examples, mostly from using SMAP data, but the same type of studies can be done with a different technology, for example, GNSS. It's not, the objective is not to talk about SMAP, but the objective is to show you the value of soil moisture for doing water cycle studies or stream flow or other science applications which are very important for soil moisture. So I will start off with this animation which I put together a while back actually when Chairman ISRO had visited us in early 2023. This shows you the onset of the monsoon in India, and you can see the impact of monsoon, and that's reflected in the soil moisture over India. And this also shows you the floods that happened that year over northeast India in Assam area, as you can clearly see, which had large flood. And in early May, as you know, that's when the monsoon starts from the south and slowly progresses north. Um, and then you can clearly see the change in soil moisture over the 2-3 month period. And this is from SMAP observations, but you can use a different platform for doing similar type of studies. There were also some floods in Gujarat and Pakistan area during the same year. So clearly, this monsoon can be captured using soil moisture, which you cannot expect. So why is soil moisture important? So this is an image of root zone soil moisture, which currently we are producing using SMAP observations along with a model which provides you the ability to do root zone, but very low frequency GNSS observations, for example, using P-band, can give you direct estimates of root zone, which probably Jim or covered in their presentations. So the reason soil moisture is important because currently they are only sparse ground observations and have limited geographical coverage. There are a number of in situ validation networks in US, but other parts of the world, especially when you get to Africa or Asian countries, then the amount of soil moisture data that's available, ground data that's available, is relatively sparse. Moreover, there are a number of different technologies, even in in situ observations, and then putting it all together, it's a challenge, whereas using a satellite can give you wall-to-wall coverage, very good accuracy, fairly good resolution, and you can have satellite observations every couple of days, which will give you very consistent observations at a global scale. And those observations can help you understand, uh, do the science work that's needed to understand the processes and the linkage between the water cycle, carbon cycle, and the energy cycle. And also allows you to quantify some of those examples that we will be seeing in the future slides. So in terms of uh, some of the applications, soil moisture is very important for water sources as well as food security. This is a slide that I put together a couple of years back, and this was an article which was there in Wall Street Journal, which talked about the unusually dry weather conditions in the US, China, and Europe, which were happening at the same time, in 2022, which was putting large pressure on the three largest economies of the world, and which was impacting trade at that time because of the dry conditions. There was pressure on agriculture, which has a big impact, as you can imagine, on the crop and food security. Soil moisture is an important indicator for farming or agriculture. If there is a scale drop in soil moisture, or you need the soil moisture because of vegetation stress, then if you have a capability, you can irrigate the field, so it determines water resources. And also, you will see that it is also a very key indicator for predicting crop yield. The yield that you count out of the agriculture determines on how much moisture is available to the plant, as we see in a later study. Some of the other applications that we go briefly is weather forecasting, ECMWF, which is a big, operational forecasting system. They are using soil moisture observations from, in this case, SMOS, and then USFS, which also, and GMAO are using SMAP observations operationally. Canadian Weather Agency also has been doing assimilating SMAP observations in a research mode, though they are not operational yet. And as well as US Navy has been using SMAP observations on the research side. On the agriculture side, number of US agencies within USDA are operationally using SMAP observations, both at domestic scale as well as at global scale. Besides that, I also know of a number of private companies which are using soil moisture observations to do their own crop yield assessment and other applications on the private sector side. Soil moisture is a key indicator of drought. It is the soil moisture that determines agriculture drought. That's how agriculture drought is defined. And this is two images from the same time, a couple of years back, when I had put this slide together. This is, the first one is from the National Drought Mitigation Center, which provides drought severity map. And the second one over here at the bottom is the SNAP soil moisture anomalies for the same time. And you can see there's remarkable correspondence in terms of spatial similarity between these two images, where you can see that the southern part of US, which is Texas, Oklahoma, and though that area has a drought, and that also has a negative soil moisture anomaly at the same time. Obviously, it also depends on your land cover. In forested areas, for example, which is in the northeast, uh, you may not have a drought for agriculture, or you may not have a severe drought because the vegetation tends to store the moisture as compared to more arid areas which will try to lose the moisture more frequently. Besides the drought, obviously it has forest applications, as you can imagine. Uh, so moisture is one of the key indicators for fuel loading, and it has wildfire applications. It's an important parameter for determining pre-fire as well as post-fire applications. Pre-fire, if you have very dry conditions, that will lead to more potential for wildfire. In post-fire, it's very important because wet conditions is what's going to lead to debris flow when there is rain or in an area which has suffered wildfire, and that has implications from a water quality standpoint. And obviously, it's a key indicator for flood forecasting because that's the parameter that separates how much water is going to flow on top of the surface and how much of it is going to infiltrate into the ground. So that's a key variable for any surface hydrology or for that matter flood forecasting. It's also important for landslides. Landslides happen when there is very high moisture along with slope, which leads to landslides generally. Number of these applications are possible only by assimilating or using these observations along with the model. An example of that is a model that we have developed at NASA, which is called the Land Information System, which enables assimilating these satellite observations and trying to do some basic and applied hydrology research. And it has been used for a number of different uh, land surface parameters as well as different missions, starting from soil moisture to precipitation to vegetation parameters. It is also a system that is occasionally used in NWP forecasts by US Air Force as well as also used by the USAID side of things. So currently that's big issues. So we earlier talked about, soil moisture is a very, very small component of the global water budget. But I wanted to use this example, this study, to show that even though it is 0.01% of the global water budget, but it's a very, very, very important component of the water cycle. And the reason I say that is surface soil moisture is the gate through which all land atmosphere exchanges happen. And this is a study that will look at the water flux. By flux, I mean is water that is changing on a daily basis. Some of the components that we identified earlier in a slide is fresh water. A lot of the fresh water is in groundwater. That does not change from a day to day. A lot of the fresh water is in glaciers or in ice caps. Those don't change day to day. It is the soil moisture that changes from soil moisture to water vapor. And then once it rains, it becomes soil moisture. So that's the flux variable that is constantly changing. Other freshwater variables don't change on a daily time step. So that's a very key parameter when you're looking at the water cycle or the water flows. It's another study where they looked at uh, different regimes. By that I mean is they used soil moisture along with ET data to identify which areas are water limited and which areas are RG limited. By water limited is by meaning which areas have less water and the energy cycle is driven by the water cycle because of scarcity of water. On the other hand, the more vegetated areas where there's plenty of soil moisture are energy limited. Uh, so you can use the soil moisture information as well as ET information, for example, LXC, uh, to identify which areas are water limited, which areas are energy limited, and which areas are going through the transition. So this helps you understand where, yeah, if you have increasing desert areas or what the impact of the changing climate is on the water cycles. And these areas, if they're changing, those are the areas which are the tipping point, essentially. And those are important to identify. This another study that looked at the different regimes from a land atmospheric standpoint. Go over the skip over this. This is another study where they used satellite soil moisture as a gauge. Instead of having, a gauge, you can think of the soil moisture itself as the gauge. So you have the top surface of soil moisture, which is where all the rain that happens goes through. Either it goes into the ground. So the change in soil moisture, if you track on a day-to-day basis, happens only because of rain or infiltration. So that can become a precipitation gauge in a sense, if you can tune that for up every location. And then you can estimate the precipitation based on that. And they compared that with IMERGE data, which is early release. And early release does not have gauge information assimilated in it. And they showed that uh, satellite soil moisture compares very well with early release. But when they looked at late release or gauge and corrected, then IMERGE tends to start doing much better as compared to satellite soil moisture. But for early release, satellite soil moisture does a very good job. It's another study where they looked at using soil moisture and assimilating it to do runoff estimation over Indian subcontinent, especially they looked at the Indus as well as the Brahmaputra rivers. They looked at stream flow change for different seasons. They divided it up into summer and winter, and they noticed that it has a slightly different behavior, and that can be captured because soil moisture change during those seasons. How am I doing on time? Let me skip this. This is a study where they looked at using soil moisture for doing wildfire detection in terms of using different thresholds, and then compared uh, that with MODIS estimated wildfire coverage maps for 2017. The major wildfires looked at those, or the mega fires. This is a study where they looked at the different mega deltas on a global scale. I believe we looked at 50 deltas, and based on their latitude location and correlated inflow, which was estimated using soil moisture and assimilated in a model, and that was compared with salinity because soil moisture becomes steam flow becomes freshening of the ocean. So there was a good correlation that was observed, and that depended on the latitude. Mid latitudes had much stronger correlations. Other smaller deltas as well as northern latitudes had weaker correlation. This is a nice study that uh, put off that relationship for each of those major deltas together based on the size of the delta and other parameters. Let me skip this. Would give enough time for agriculture as well as myself. This one they correlated soil moisture with vegetation, especially NDVI. Soil moisture can be a lead indicator for predicting vegetation growth. If you have low soil moisture, then vegetation is not going to grow very well. And if you have good soil moisture, then it's likely that will lead to good vegetation growth. So they related the soil moisture to vegetation and on good correlation and with a 14-day lead time. This is some of the operational applications that we have done for USDA, where we have put together an application where they are operationally using the system to provide weekly guidance on soil moisture for agriculture. These are there in the weekly reports that USDA is mandated to provide to the farmers for different states. So that's provides them guidance in terms of field conditions, when is a good time to plant or doing farming operations. And it's also used, as you can see, in laser slides for doing crop yield estimates. Then this is an example that shows the use of soil moisture for doing determining water demand or irrigation for Haryana and Punjab areas, which are, as you know, very agriculture dependent. And this was done for 2017 and 2018 and 2020 periods for those states. In this study, they basically used soil moisture for determining which are the irrigated areas. So they were able to use the soil moisture information to identify irrigated areas because if you have precipitation, then soil moisture may increase. But if you don't have precipitation and soil moisture increases, that's likely because of irrigated conditions. So determining those locations is very important, as you can imagine, for water resources purposes. A case study I wanted to go over where we are assimilating different remote sensing observations and coupling it with a hydrology and a crop model. And that allows us to demonstrate the value of remote sensing observations from various satellites. In this case, we are using soil moisture as well as vegetation information, along with state-of-the-art crop model and the state-of-the-art hydrology model, which are fully coupled, where you're passing soil moisture between the hydrology model to the crop model, and then passing the vegetation parameters back to the hydrology models. And this was run at a 1 kilometer scale over the state of Iowa, which is a very heavy agricultural state. And this was done for both corn and as well as soybean, and this also shows you the root zone soil moisture for 2 different years. 2018 was a normal year or a good year. 2021 was a very dry year, and then you can see the impact of the weather conditions on low soil moisture on crop yield, and we were delighted to see that impact because if we know the soil moisture is bad, but we don't know if the system is able to capture it all the way to crop yield or not. So this data was aggregated to county level because USDA does do a survey at county level, and we were able to compare that for corn and soybean over the 7-8 year period at county level, and this shows fairly good comparison with very low bias. Some of this scatter, and most of the scatter is because we are not tuning the model currently. We don't have information on the field management practices that a farmer is doing in their field. So because of that, different farmers have different practices which probably need to scatter. But assuming that farming practices don't change, you can look at anomalies. Anomalies are very, very powerful because your average, the deviation from the average is what determines whether you have a lower yield or higher yield, right? So this shows you using this system, we were able to do corn yield as well as soybean yield. This example shows you the corn yield anomalies for different years over Iowa, all the way from 2015 and 2016, which are good years, and then 2020 and 21, 22, which were not so good years. Then I wanted to show you 2020 as a case study. A lot of the problems with 2020 were driven because of straight line winds, which damaged a lot of the standing corn. This was a storm that tracked through the central Iowa. You see the storm come through very soon on the next red animation over here, which essentially flattened the maize or corn fields. And this was observed by the MODIS satellite. This is a MODIS image before, and this is a MODIS image after the event. And this is a difference which we were able to assimilate into the system. Right now you see that cell that created the straight line winds on the next slide image. And these are the absolute crop yield anomalies from the system as well as from the USDA NAS. When we look at the anomaly data, these observations compare fairly well with the model estimates, which used MODIS as well as MAP data for assimilating into the crop model and then predicting crop yield for 2020. And this was only possible because of the remote sensing data and the powerful modeling platform that we built. So this is an example of a study that we've done, which shows you the value of soil moisture as well as vegetation information from different satellites and determining agriculture productivity or food security. Next, I wanted to take the time and then give like probably 15 minutes for questions, unless there are already questions that they are there. So I wanted to talk about NISAR. NISAR, as you probably already know, is slated for launch in a couple of months. So NISAR has a number of different science objectives. It has objectives in cryosphere sciences to study the ice sheet and glaciers. And then it has objectives on the ecosystem side to study biomass and permafrost in wetland areas. It is also going to be used for doing solid earth studies, namely earthquakes, volcanoes, and landslides. And on the application side, it's going to be very important for understanding that water cycle dynamics as well as carbon cycle, then a CO2 sequestration in vegetation as well as reservoirs. It'll also help with agriculture monitoring as in the support of food security objectives and help with urgent response because it can map earthquakes, volcanoes, flooding, and other disasters. So how is that going to be done? NISA will have two radars. First one is going to be operating at L-band, which is 27 centimeter wavelength. And the second one is going to be operating at S-band, which is about 10 centimeter wavelength. It's going to use a sweep SAR technique with a swath width of 240 kilometers. So every time satellite goes over, it will cover an area of 240 kilometers. It will have different variations depending on the location. Some areas are single pole, some areas are 12 pole, some areas are quad poles. We have an equation map. And it'll have an exact repeat of 12 days because that's very important for doing interferograms, which is important for doing disaster mapping. It'll have a resolution of about 3 to 10 meters in single look, depending on the mode or the bandwidth. And I'm currently for a baseline mission of 3 to 5 years. It's going to be left looking, so by that I mean it's going to have a bigger hole in the north, on the North Pole, and a smaller hole in Antarctica. Most of the radars are right looking because they want to cover the northern North Pole better. But because Sentinel and other Pulsar and other satellites have been right looking, NISA decided to be left looking so to get a better coverage of the Antarctica using the radar observations. The incidence angle is going to be between 33 degrees and 47 degrees. It'll have a sun synchronous orbit with a overpass time of 6 a.m. 6 p.m. So NISA has been possible only because of a true partnership between US Space Agency, NASA, and ISRO on the Indian side. There are different subsystems within ISR and equally contributed by the two space agencies. NASA provided the L-band SAR, ISRO provided the S-band SAR. NASA provides the instrument structure as well as the radar antenna, which is a 12-meter antenna. So it's a fairly big antenna. The spacecraft and the launch being provided by ISRO. So it's an equal partnership between the two space agencies. Currently, the science team as well as the project team and the comms teams are working towards a launch, which is imminent. There is a handbook which we are in the process of revising, and then there should be a new handbook which should be released prior to launch, which provides you all the background information about the science and applications from the NASA missions. This shows you the observation plan and the different color codes show different bandwidths as well as different modes. So some areas are going to be dual pole, some of them are going to be quad pole, some of them are going to be single pole, some of them are 5 megahertz, some of them are 40 megahertz. So depending on the bandwidth as well as polarization, the resolution is going to be different. And uh, these were determined based on which area has what type of science needs. For example, Amazon area uh, was driven because of ecosystem needs. Uh, Other areas, for example, Antarctica was given based on grassland needs, and land. This area was driven mostly because of ecosystem or land parameter needs. So depending on the application of the domain, the mode changes. This is another slide which shows the coverage map, because one slide was not enough for doing the coverage map, and we needed 2 slides. The NISAR will be connected to the on your land. There will be some data collected over the oceans, mostly in the ocean and Bay of Bengal, as well as off the coast of US. Besides that, they probably will look at augmenting the plan in future based on what the requirements and needs are of different communities. This is a table of the bandwidth versus resolution. So depending on your bandwidth, your resolution changes. So depending on where you are, and the bandwidth is going to be different, and then resolutions will be slightly different. But all that data is also going to be posted on 30-meter GCOF grid, and that will be used for doing higher level products. The single loop will be aggregated to multi-loop, and then that will fed into doing science variables. Some of the science variables which are plant are woody biomass, vegetation disturbance product, which will be done for validation or validation sites, as well as wetlands, crop area, variables. We will also have a global soil moisture product, like 1 meter resolution, except over Sahara, which is 50 to 400 meters. The requirement was 500 meters, but we plan to do 400 meters because it's even multiple. Besides that, they are also planning to develop additional products like, for example, global surface water extent, global disturbance product, as well as deformation product, using the opera system, using NISAR observations. This shows you the commissioning plan from NISAR. So you have day 0, which is essentially launch, and then we start collecting data around day 50, because they have to do a number of different engineering activities in terms of checking out the spacecraft, checking the deployment, checking out the instrument, and hope to have first light images around day 60, 70 time frames, and then move into a science orbit probably around day 50, and then a first light image, and then hopefully release the data in 3 months after launch. And the first light will be about 70 days after launch. But all that depends on how all these activities go post-launch. Okay, so I mentioned about the plans for having a global soil moisture product using NISAR. If I change it to 2024 to 2025, so it's like, sorry. So we will use L-band observations for doing global soil moisture, and the soil moisture map will have a spatial resolution of 200 meters. It'll be 6 days when you combine both ascending and descending modes, because the repeat is a 12-day repeat, and we have accuracy goal about 6% soil moisture over low to moderate vegetative conditions. Over forested domains, we will have a much higher, we might have a higher error over very dense canopy. We will exclude soil moisture over areas which are very steep terrain, or when there is active precipitation, or if it is frozen ground, or those type of conditions where it does not make sense to do soil moisture. We'll also validate the different algorithms using either airborne observations or SMAP radar, and we have tested these algorithms using UAVSAR, which you can see over here. This is a series of UAVSAR images which were observed in 2012 over an agriculture domain in Canada for a 1 month period. And these are retrievals using one of the algorithms, and you can clearly see the precipitation dynamics over this large domain. This is about 30 kilometers wide and about 100 kilometers long, 250 kilometers long. So it's a pretty big area. And at the beginning of the experiment, there was precipitation, and then there was a good dry down, and then we had another precipitation event. And then in the end, we had another precipitation event, which was over the entire domain. You can also see this domain, the southern part is agriculture, the northern part is forested, and some of that can be seen in these images. So this shows you the map of exclusion zones. The pink areas is where we will not have retrievals. Essentially, this is water bodies or frozen areas. And to have a latency about 70, that latency when we. So this is latency after the level 1 levels. This shows you the flow chart. So essentially, the GCOP data, we have a hybrid filter. GCOP is a 30-meter resolution. We aggregate it to 200 meters and then feed in the X-ray data. We do the flagging, and then we can decision whether we do the retrieval or skip the retrieval, and then also do another vegetation check, and then perform the retrievals and deliver the product. We plan to have 3 different algorithms as part of the product. The first one is a physical model. The second one is based on a time series approach, and the third one is based on a multi-scale fusion algorithm, which uses a model to descend along with the NASA observations for disaggregation. The first one uses a data cube approach, where you have 3 axes. The first axis is directed constant, which is what is used to do soil moisture estimate. The second axis is vegetation water content or the vegetation parameters. And the third axis being the surface roughness. And then there's a lookup table or a data cube for each land cover type. So depending on the land cover type, you have 3 different variables, and those are used for doing the retrievals depending on what your backscatter coefficient is, and then retrieve these. The second approach is a time series algorithm approach. This is the example that I shown earlier. We use a time series to minimize some of the parameters, for example, roughness, impact on roughness and vegetation, and If you take a ratio, they can cancel out for in a different components. And the images are shown, and this is the validation over the same domain using in situ observations using HH poles. But we can also do it, the same retrieval using VV pole or combine HH plus VV both. Third algorithm that we are deploying is uses ECMWF or ERA 5 model estimates along with ISR observations uh, to disaggregate, and then it uses a beta and a gamma parameter based on the location and the vegetation conditions. So much estimates I included solutions. Besides that, ISRO is also developing soil moisture algorithms at 100-meter scale over India. Dharmendra may have talked about more about this, so I'll skip this ISRO algorithm approaches. So if you have any questions on ISRO algorithms, please contact Dharmendra, which I believe you have his contact information since he gave a presentation yesterday. We are going to be validating these products, and validation is very important, not just for LISA, but for SMAP as well as for any GNSS or any satellite observations. How good your retrievals are, you can only find out if you have one truth. And these are some of the networks you're trying to use for validation, which are in the US. And we also have networks in India that ISRO is developing. And you can ask Dharmendra more about some of these networks in India. Generally, the approach is we'll have multiple observations within in a single grid cell for that grid cell to be determined as a core or a radiation site. But we'll also use sparse observations, which are single points within the grid cell. For example, those are for networks which have only one incident sample in a grid cell. So we'll use both sparse as well as dense networks for validation, or use any data that we can find for validation. This shows you a strategy that we have. We have cascade of sites. Some of these could be a score, some of these could be sparse. So you can have the dissected over here, which may have multiple of these, and then you have a bigger domain, which is map domain, and you have multiple observations within that. Some of them could be manual sampling, some of them may be permanent stations, so it can be a combination of either manual samples along with permanent stations. The manual samples will help to calibrate the permanent stations, which are less spatially distributed as compared to sampling. So these are some of the applications that are planned as part of the NASA missions. So we'll be able to do a crop state and yield, we'll be able to do soil moisture, we'll be able to do water extent mapping, ice sheet, volcanoes, oil spills, hurricane winds, deformation, disturbance, which is tornado damage, for example, disaster mapping. These are some of the pictures. This is where the original picture that the project had at the initial stages. This is a picture later on, which looks very similar to the conceptual drawing. This is a picture in the clean room, JPL. These are pictures in the vibration testing. This is a picture that was taken last year in Bangalore in the clean room, which it was vibration testing. These are some of the applications that we already saw during the presentation. I think with that, I'd like to open the floor for any questions that I can help answer. Hopefully, this was clear. Unfortunately, I couldn't be there in person. Interact more with you.
Yeah, thanks, Rajat. Are there any questions?
So the objective of this presentation was not to drill deeper on particular topic, but give you more of an overview of the different applications that can be done using remote sensing observations in general, and the value of those observations can certainly look at individual papers. But hopefully this gives you a flavor of the value of these observations for various societal applications as well as doing science.
Yeah, thank you so much, Rajat. Are there any questions from any of the participants? Okay, no. Rajat, can we share the slide deck to with them, with the participants?
Sure, I think you have a PDF
Yes,
copy.
yes, I have it.
PDF. Yeah.
Yeah. Yeah, thank you so much for the wonderful presentation, and definitely we all are looking forward for the NISAR launch. It is a very excited mission, and we are all. I remember when I had a discussion with Paul, because he is frequently visiting here for NISAR mission. So we'll take a break. We'll come back at 10. Okay, one question is there. Sushant, you can come in.
I hope this time
Yeah.
you can
Yeah,
understand.
yeah.
Can you sir say, can you share the data that you have shown for the soil moisture for the UAV SAR? Actually, we are working for that one, and we are actually calibrating the NISHAR data. So we have some data for the UAV SAR, but we have used that for the only calibration purpose. So can you share this kind of data so that we can work on soil moisture also?
Yeah, so EMSR data is can download it from Alaska Soil Facility. You go to the EMSR. So in this case, EMSR operates generally at 80 megahertz. One of the things that the project did was
So
did
so what is the specification for this one UAV SAR which you have used for the estimation, soil moisture estimation? Means the
so go ahead.
I just want to know about this data, which data you have used for this one. We have seen that UAVs are data, but I don't know about which data is exactly this one. There are lots of the data is there. So exactly which one has been used in this research work?
Yeah, so that's interesting is here we saw more data as 80 megahertz. One of the things that the project did was simulated diagrams like you data using UV observations. So if you search for NISA simulated observations using UVSAR on the ASF site, you should be able to download that data. And the reason I mentioned that particular data, unlike UVSAR, which is 80 megahertz, which is a long noise flow, NISA, even though it has very low noise flow, it is not as low as UVSAR. So they aggregated for 20 megahertz, simulated for 20 megahertz as well as 5 megahertz, because EV is 5 megahertz, HH is 20 megahertz, and that is also available at ASF, and that's what was used for doing these runs, because you wanted to use the UVSAR data that was simulated for using NASA specifications. And then those backscatter observations were fed in a time series algorithm and then estimated saw moisture using that algorithm. And then it was compared it to incident observation, which is also available on the SMAPFlex site at NSIDC, which is National Solar Ice Data Center, which is the location for all SMAP validation experiments. So these are different crop types that were present over this domain, and you should be able to get the in situ data from load diagrams.
Thank you, sir. Thank you so much.
Thank you, Dr. Rajit, for the informative session on GNSS-R and applied case studies. Uh, Thank you so much, sir. And now we'll have a small break and we'll continue the session after 11:15.
టీ బ్రేక్
of introducing Dr. Rashmi Shah earlier in the workshop. She is now joined by Dr. Mosmi Ajay Chaurasia, professor in the CSE department at KL University, Hyderabad, and our IEEE student branch mentor. Dr. Chaurasia is a senior IEEE member and GSS IDEA co-chair who has contributed extensively to IEEE roles in Region 10 and GRSS. Please join me in welcoming Dr. Rashmi Shah and Dr. Mosmi Ajay Chaurasia.
Thank you. Now, question for everybody. How many of you actually know what GRSS is? All right, we have a couple. Professor Chaurasia here will give more detailed about the society in general, but I want to focus a little bit more on the technical committees that are within the society, specifically the instrumentation and future technologies, which is I'm the chair for that, and that's this technical committee that's sponsoring this event. So I just want to talk a little bit more about what we do and how can, if you have interest, how can you get involved in such a technical committee. So GRSS is a society within IEEE. It stands for Geoscience and Remote Sensing, and within itself, they have, publication aspect, education aspect, industry aspect, professional activities, chapter activities. But one of the prong of it is technical activities, and it's the VP for technical activities is Fabio Pasifia. He's in the US, works for Maxar, and within him there's 8 different technical committees, which ranges from, I like to say that we are the base, instrumentation and future technologies, the base of collecting data, all the way to application, which is the remote sensing, environmental analysis, and climate technologies. So the REACT. But within that, there's many others, right? There's the earth science informatics, frequency allocation in remote sensing, geoscience standards in earth observation, geoscience spaceborne imaging spectroscopy, image analysis and data fusion, modeling and remote sensing. So it covers all aspects of geoscience and remote sensing. That's pretty much what it is. And we do activities like this and many other activities. All right, we're going to work on next slide. All right, so instrumentation and future technologies. I'm the chair, and I have 2 co-chairs for my committee. It's Delvin Moeller, who's in New Zealand, and Dustin Schroeder, he's a professor at Stanford. And between the 3, we have different responsibilities. Dustin, for a while, was doing all the webinars that has been done. Delvin has done some activities, and I'm going to talk about that, and I tried to lead the overall thing. And within our technical committee of IFT, I have 6 different working groups. And it covers different aspects of all the instrumentation. Some you have heard today in last 3 days, some which is in the optical side. So we have active microwave, which is the radar, active optical and LiDAR, GNSS and signals of opportunity. It looks like some of the things have gone under, so it's some of the words are under, but you can I'll show you guys the website later. You can go look at it in more detail. Passive microwave, remote sensing instrument for small satellites, and remote sensing instruments for UAV and UAVs, which is the last one. And each one has working group chairs or co-chairs within it, so you can see their name. And I have a link at the end to the website, so you can go look at these people, and you can actually get their contact information as well if you're interested in any of these different things. And each of these working groups does their own event and plan their own initiatives within it themselves too. And we had at least one presenter, Sachi, from who talked yesterday from this committee. Now, what are the things we do? We do monthly webinar. That's organized now by Sean Peters. He's a professor at University of Colorado. And it touches on different topics of IFT. These are the last few that we had over the last quarter. And you can see it talked about high altitude platforms, INSAR, radar stuff, polarimetric SMAP, and then Snoopy mission that Jim talked about too. And then one of the other, and I'm just highlighting some of the things we have done in recent times. There's a lot more information, but one of the other things we did was Felipe talked about the GNSS-R instrumentation yesterday. We have taken that hardware and his software and have worked with high school students in New Zealand, where they built their own instrumentation and put it in a farm first and then a local ski resort to get snow depth measurement and really learn about remote sensing. So we're trying to really target people early on, in remote places who do not have access to practical applications and really get them interested in it. So we did this last year in New Zealand where we had 3 students and they ended up presenting at a national conference in New Zealand at the New Zealand Aerospace Summit. So they actually ended up going to the conference and presenting it, and also ended up being a finalist for one of the most prestigious scholarships that they have in New Zealand. So it actually had an impact in the students over there. We're doing this again this year in New Zealand with 10 students in 2 different schools. So we're trying to expand it. And then eventually we do want to bring it once we have figured out a way to, there was a lot of lesson learned the first year. The bill of material is great for one environment, but in the snow environment, we need a little bit more power because when things are cold, it requires a little bit more power. And so we looked at some of the things and we have figured out a way to ruggedize it. And right now we have an intern who's looking at developing a user guide for this as well as new bill of material. And we plan on publishing that, and then also trying to see if there's interest in expanding it beyond New Zealand. So if you have interest in something like this, doing something along that, we can talk a little bit more for next year or the future years. And then we also do a lot of community contribution sessions at IGRS. And these are curated special topics in IFT in general. And this year, each of my working group is doing their own community contributor session, and then I'm leading something on unlocking the potential of HAPS, high altitude platforms for Earth observation, because I believe, the future technology part, that's probably at the prime where we can actually start using it for remote sensing. So we're trying to bring that into IGRS as well. And then some of the other activities that are ongoing. I mean, this workshop is one of them. But then in 2 weeks, we have the GNSS Sensing List of Opportunity, the GNSS+R 2025. This is a conference or a workshop that happens every 2 years. And it brings all the GNSS-R community together. And it's a specialist conference or meeting per se for the topic. And this year it's in Leiden. And then in 2 years, there's going to be a call coming out and people can apply to organize that thing. And then we have a committee that will select where it will happen next time. So it's sort of like, it's about 100 and 120 specialists from around the world who attends that workshop. We have something similar in space LiDAR workshop that happens as well. And this is led by Upendra and Georgios. And this year, that's going to be happening in Montana in November. Then we have our radar working group lead, Michelangelo. He's a GRSS distinguished lecturer as well, and he's going around talking about SAR and other aspects of things around the world. Our radiometer group is looking to do a summer school in the topic of radiometer. So one of the things technical committees also do is they do summer school once a year. And this year, we have some leftover funding from last year, and that's what we're using to do this radiometer summer school. But I do have some funding to do another summer school if there's interest in IFT-related topic anywhere. So that's something to, and summer school is a misnomer. You can do it in fall as well. And then next year, our UAV group is trying to use that fund to do another summer school. So that's, every year we have some funding for something called a summer school that we try to use as well. And I think that's all I have. Any questions? Actually, I had one more slide. It was information about how to join. Is there, can you put the PDF up? Oh, was it? I guess I sent the slide before I saved it. Because I have QR codes that you guys can use to figure out how to join. All right. So, two different things I have a QR code of. Here, if you're interested in joining IFT, you do not have to be IEEE member to get our mailing list or get on our mailing list. So that's the list, that's the link for you to join IFT. We send out a quarterly newsletter of what's going on. And you can email me at any point if you're interested in linking with somebody and doing some volunteer activity. And the second one is not just IFT, but there's a lot of educational resources that GRSS has put together. It's all free on YouTube, and that's the link for that, that you guys can look at. And if there's, I know many of you had different topics that of your research, so you can go and look at webinars or any kind of educational resources around your topic in there as well. All right, thank you. Any questions? All right.
Good morning, everyone. I'll be taking the session on behalf of Avik Bhattacharya. He was supposed to be here, but due to the different commitments, he could not come in person. So I'll be talking more about GRSS, how GRSS supports the professional as well as the student members with respect to the personal and professional growth, and what are the various benefits. You can take it for yourself and for your family as well. Okay, well, yes. Next. We all say it is a very obvious for every IEEE member. You will listen, IEEE is our professional home. Why? Everyone has three lives. One is family life, one is professional life, that is job life, and everyone has a two life, one is professional life and a family life. We call it IEEE as our third life, third family. IEEE is our home. IEEE is our family. So there is a very famous, if you search it in the Google, it will be IEEE is a professional home. You can see it, a very beautiful video which you can utilize in your all the membership drives in your section, chapters or your student branches to grow the membership. Next. Yeah. GRSS is a global community. We have established in 1961, transformed the GRSS in 1980, and day by day we are growing very strong. We have, in IEEE, we have total 39 technical societies that fosters not only the member engagement, but the commitment of all the IEEE volunteers is to grow in a group. Alone, we cannot grow at all. To grow in a group, everyone would like to give back to the society from where they have earned it, but they don't want to lose their connectivity. So we all are technical persons. We would like to be connected technically. That is the IEEE is a professional home. We are growing technically. We are volunteering technically. So we have the governance, that is all the GRSS society is maintaining and having all the respective societies, respective domains. We have one or the other members representing, as Rashmi is representing IFT. I am representing IDEA, that I'll be explaining in the future. So we all comes under voting or non-voting GRSS ADCOM. And GRSS ADCOM meet thrice in a year to discuss, to strategize, to add more initiatives to the GRSS for the volunteers, for the members, and how we can benefit to them. Our scope includes the theory, concepts, all the techniques related to the earth, oceans, atmosphere, space, disaster management, agriculture, hydrology. So all this is, if you see, all these are related to though GRSS, but everywhere AI and machine learning comes into the picture. Whatever field you take it, by default nowadays these buzzwords have come up, and wherever you connect, you just connect the AI technologies along with the current going research ideas. We are total, this is maybe 1 month old data. So far we are 7,600 plus GRSS member across the globe out of 144 countries and 168 chapters across the globe. Day by day we are increasing, and we really want the members to join GRSS because it has a very wide variety with respect to publications, with respect to grants, every international conferences organized by GRSS, you will have the travel grant. And we make sure it is not about the volunteers or members to attend the event. It is how we can support them so that they can contribute to the society by learning and by gaining the experience. Next. Yeah. We have a very good publication sector, and the good part is just 2 years back only we have a GRSS special column in IEEE Access, and that gives the review time in 4 to 6 weeks only. So we have a, if I can, okay, here it is not showing. You can see at the corner, no, earlier slide. Yeah, you can see at the corner, it says GRSS, IEEE Access. It is just after so much of efforts, we have made GRSS presence in the IEEE Access. And we have other GRSS 4 refereed publications, that is TGRS, GRSL, J-Star, GRSM. Not only this, these 4 publication journals have always called for editor-in-chief, reviewers, which will always benefit you. So you have the option, either you or your professors or your senior scientists will have the option to volunteer to support the GRSS. Not only by attending the events, but being a reviewer, being an editor-in-chief, that always adds to your CV. Next. This is the technical activities. Rashmi has already explained. These are the 8 technical activities you are seeing. Every year they organize the summer school. Summer school, we say it is not organizing only in the summer. It is throughout the year, so even though it is fall or winter, we call it as summer school only. It is a specific educational school which is dedicated in a particular theme, and they teach it along with the tutorials, along with theory insights based on that particular theme which is in demand. Next. GRSS not only provides the education side, but they also provide the networking to all the volunteers and the members. GRSS have a very good flagship conference in 2024. It happened in Athens, Greece. As you can see over here, there were close to 4,000 submissions, and out of that 3,000 submissions were accepted. This year, the same IGRS is happening in Australia, Brisbane, and above 4,200 submissions have done, reviews are done. Now travel grants, I think some of you have already applied for the travel grant for IGRS. Anyone who has applied for travel grant to IGRS? I think, yes, I can see, yes, 2 members I have already seen. Even travel grant is not only for students, it is a travel grant. It could be for researchers, it could be for scientists, it could be me, it could be for anyone. So student travel grant mentions only for student, but travel grants is for all. And what all it covers? It covers your flight charges, it covers your accommodation and the conference registration. Conference registration itself costs $950. So that all gives flight cost, it needs around $1,500. So it covers the major of the part which is required to travel or to get accommodated in the conference. No, earlier slide. Yeah. Next year, from where Rajat could not come, next, am I right? He is from DC, right, Rajat? So he is in DC, and next year IGRS will be in Washington DC. So any of you who are willing to meet Rajat other than India, because mostly he'll be coming for NISAR launch as well in Ahmedabad. So please do submit once the call for proposal comes out, call for papers comes out for IGRS 2026. Other than that, these are the global scale conferences. Regional conferences also happens with GRSS. Regional conferences in India, the regional conferences in INGARS. I think every one of you knows about INGARS. Last year it happened in Bombay, Goa. Yes, NIT Goa. This year it is happening in IIT Bhubaneswar, and hope next year in 2026 we'll bring it to Hyderabad. We have another Mediterranean and Middle East Geoscience conference, that is M2GARS. We have LAGARS, that is for Latin America. And next, this is the conference TCS by GRSS. This is happening in this year on 17th and 18th of September. Call for proposal is on, call for paper submission is on. It will be ending on 15th of April because we have done only one extended, and we cannot afford more of the extension. If any of you are interested, please do submit your papers or do contact me. Next, these are the other co-sponsored and TCS conferences. It is GRSS is not only spread in Latin America and in Africa, in India, across. If you see here, you will see the GRSS presence across the globe. And we encourage such kind of conferences. If any of the institute would like to organize the conference, they can reach out to the society. There is a form, you can submit it, you can provide the requirement details, and then ADCOM will be looking into it. Next. Yes, we have a GRSS distinguished lecturer program in which few of the members across the globe, they will be recognized based on their expertise as a distinguished lecturer. So they have the tenure of 2 to 3 years. They will be visiting places from wherever they will be called, and they will be giving lecture on their expertise. As we have already seen James Garrison, he was here. From this year, his distinguished lecturer, I think he'll be there as a DL for 2 more years. We have Professor Gulab Singh from India. He was the general chair of INGARS of last year. We have Professor Kumar. You can see here, she is from Argentina, Ana Villa. She will be coming here in September for the Earth Sense conference, which is happening in here. In this IDEA, I belong to this committee, that is IDEA, Inspire, Develop and Empower and Advance. In this, we have several initiatives. The first and very famous initiative is microgrant. Microgrant comes here. I cannot see the picture. Okay. Microgrant is, there are 30 awardees, and each awardee will get $500, which can be utilized to attend the conference for your field work, except any laptop purchase or any hardware big amount that will be excluded. Otherwise, field work is included. Any online courses which is quite expensive and which is related to your domain, that will be covered. Any regional conferences, that will be covered. Any learning network, or even IEEE has the learning network, from where any certification course where to enhance your career, to enhance your technical domain, everything can be applied under microgrant. And we have 30 awardees for that. And the same for the females, it is exclusively for females, that is family care grant. From this year we have started, we are giving 60 grants for this. I think again it is of $500 each. All the females who are having a small kid or a young kid, but they would like to contribute to the research, they would like to continue their research and the field work, so they can apply over here. In the conferences with a kid, it is quite difficult. So under applying this, they will be getting the $500. There will be a child care room in that particular conference, and a child care facility. All the facility will be there. So there it is a small crutch called in every conferences. Earlier slide. Yeah. In IGARS, in all the IGARS, you can see here elevator pitch competition, 3-minute pitch competition, 3-minute thesis pitch competitions are there, where you can talk about your thesis just in 3 minutes. So it is a very popular competition amongst the young researchers and the master students and the early PhD receivers. So we have a women mentoring women program, in which the target is a very senior scientist, a very senior volunteer will support the another woman to grow the career, where it could be vice versa. The mentor and a mentee, age has no bar. It could be, mentor could be of double the age of mine. Mentee could be double the age of mine. So it is all about your expertise. It is all about the way in which direction we need the mentorship. We have podcast, Down to Earth. It is a very famous podcast. We have total 4 seasons so far. So please do scan. It is available on Spotify and Apple TV, and it has a high subscribers as well. Next. Yeah, as Rashmi has already mentioned, we have several learning spaces, that is GRSS schools, webinars, high schools and undergraduate programs. These are high schools and undergraduate programs comes under STEM activities, where we would like to spread the GRSS details or the geoscience and remote sensing, so that they can build their career in this direction. As an Indian, I feel so proud seeing so many Indians in GRSS website, either in DL or Rashmi. I feel so good seeing Rashmi over here, Rajat over here, Sanchi over here, and it is maybe in the next coming years, either one of you will reach to there. So this is the inspiration, this is the kind of motivation we all collect and collaborate with each other, that what are the job opportunities, how to take the internships. There is one LinkedIn channel, maybe I can post it in the group. That channel always mentions 20 to 30 space whenever there is an option of internships from the space organization across the globe or across India, he just posts it. So we have such kind of network. So it is we should encourage and we should motivate ourselves and get leverage from it. As you can see, there were several schools were conducted. In YouTube channel, if you see, we have the GRSS details in several languages as well, in Spanish, even in Indian regional languages also. A very basic information is there. You just type IEEE GRSS YouTube channel. You will find for your kids, for your younger sisters, daughters, siblings, you can see very basic GRSS domain, GRSS knowledge is always given. And all the technical videos, I have posted the details as well. All the technical videos are also mentioned, are also posted in the GRSS YouTube channel. Next. Yes, GRSS is a community of communities. What all we cover? We are full of professional activities, we are full of conferences, we are full of technical activities, we have publication, we have education. So it is all about your interest, in which domain you want to be. There are several different domains and different themes and different domains in the GRSS, where you can just pick it and start building your career or start building your research in that particular domain. Next. Yes, this is the YouTube channel. As you can see here, there are 4.9K subscribers already and we have 500 videos. Even this session videos, this 3-day workshop will also be posted in the YouTube. So these things you can revise it. Many of you were asking for the slide decks. So these all will be available over here. All the webinar series or the GRSS summer schools, you can find it in this. Next. Yes, it is an invitation to all the members, because there are 2 to 3 members who are have not joined the IEEE or the GRSS. I encourage and I motivate you all to come and join it, and you can be part of it. Member engagement should be done from your side. You need to find out how I can involve myself, how I can engage myself in my particular society. Every member, every faculty or student, they belong to one or the other technical society. It is up to you which technical society you are opting, and just follow in that particular domain. Definitely try to volunteer your student chapter, try to volunteer your section. This all adds your value. I started my career in 2010 when I became my first IEEE member as a master student. So since then I'm here and it all takes a while. Nothing can be this entire session. Since I think 7 to 8 months, we all are working, and because of Rashmi, I know this all event is happening, because there were there were many hurdles. So these all hiccups we all learn about, and we all are there to help each other, to motivate each other. Wherever there is a problem, please reach out to us. We are all there to help you. Next. Yes, this is the scan code. we have a GRSS membership for preferred, essential and student. Student, everyone you know there is a student membership. What is the difference between professional and essential thing? In essential, sorry, preferred and essential. In essential membership, you will get all the copies in a digital format. You will get everything in email. But in preferred one, it is, you will get the hard copy as well. Hard copy magazine, it will come to your home in your address, whichever you have registered in IEEE, and this is how you have done. Preferred membership is little bit of higher than the essential one. Next. Yes, this is all from my side. If any of the questions, I'll be happy to answer. Okay. So, yes, do you have? For student membership, it is, you can just I'll start from the scratch. In Google, you can just write IEEE membership. The home page will come. At the corner, it will be written Join IEEE. Join IEEE, if you are a IEEE member, you have to go for the add membership, add society membership. In society membership, there will be 3 points. 2 points, one is student membership, one is professional membership. Go for the student membership, automatically you will be charged for developing country charges. And you can have, I think student membership is, in INR it is 2100 rupees, including GST or something. Yeah. And including IEEE membership I am saying. So if only GRSS membership, it is just $1 or $0.5. So hardly 40 rupees or 50 rupees is the GRSS membership. Yes, thank you. Okay. You say it, then I will end up. You close it.
Thank you, Dr. Rashmi Shah and Mosmi ma'am, thank you. With this, we have come to the conclusion of 3-day GNSS-R capacity building workshop. So it has truly been an enriching journey exploring various fields of GNSS reflectometry, from theoretical foundations to real-world applications. On behalf of the organizing team, I would like to extend our heartfelt gratitude to all the speakers whose insights have made this workshop a very great success. Special thanks to Dr. L. Garrison. We had his lecture on day 1, Dr. Rashmi Shah, Dr. Sachidananda Babu, Dr. Ranjit, Philippe, and Dharmendra Kumar Pandey. Thank you so much. Thank you to all the speakers. And also we would like to acknowledge Professor Avik Bhattacharya from IIT Bombay for his valuable support and guidance in the lead up to this workshop. He was not present during the workshop with us. His impactful work in remote sensing, SAR and radar polymetry, as well as his role as the editor-in-chief of the IEEE Geoscience and Remote Sensing Letters, continue to inspire and influence this field. His recognition with IEEE GRSS Regional Leader Award 2024 speaks volumes about the caliber of researchers shaping GNSS-R, and also special thanks to our principal sir, Dr. A. Ramakrishna Garu and Mosmi ma'am. Without you have worked so hard for the event. I have been seeing you from week, yeah. So thank you all, thank you everyone, and also thanks to my wonderful fellow team members, organizing team. Thank you so much for your support, and I want to take this opportunity to thank you for giving this opportunity. This is one of the best event, me as a host. Thank you so much, thank you for having me. Thank you all, see you soon.
Just 2 minutes more. I'll just would like to express a dedicated thanks to all my team. Shadab sir, Shubhrangi ma'am, Shushma ma'am, please come forward. And this entire session was recorded, went on YouTube live, and this was not done without these 3 volunteers. Vamshi, Funny sir is not here, Kalyan sir, they were here since 2 days earlier than, from 7th onwards, they were very much worried more than me. I was worried for all other logistics, but they were worried for all. So entire AV was managed by them. Thank you so much for all your support. Chadab sir. Shubhrangi ma'am. Yes, all my students, please come forward. Yes, Shushmita. First. ये वंशी सर आप आ जाइए, थोड़ी देर छोड़ दीजिए उसको. Yeah, Kalyan sir आप भी आ जाइए, if anyone can take the mobile pic. Yeah, he has volunteered. That is the IEEE member. Please. So this is the team who has always served you and helped you throughout the event, and I wholeheartedly thank to each and every person over here. Without them, this would not have been possible at all. Thank you so much to each and everyone present over here. Thank you so much. We have a lunch at 12 o'clock. Our post session, we do not have any post lunch, we do not have any session. So you can enjoy Hyderabad till you are here. And the travel grants, next week I'll be floating the Google form to all the members. You will receive the Google form with, you need to fill the account details, your name, as exactly with respect to your bank records, and then within 5-7 days you will be reimbursed.